Good afternoon, everyone, and welcome to the session about Merck's cloud transformation being presented by Sean Finnerty. Sean is the global head of infrastructure and cloud at Merck. It's a large pharmaceutical company. He also leads a program called Blue Sky, a very key initiative at Merck driving modernization and migration to cloud. It's a huge transformation for a large enterprise and very successfully being done and delivered by Sean and his team. Today's story, Sean is going to talk about how modernization factories work. While, as I hand over to Sean before that, I do want to talk about HCLTech's partnership with Merck. We are 20 years in partnership and being a key partner in the Blue Sky modernization as well. It just puts us in a unique position, and together in last few years, we have been able to deliver outcomes together as a team for the enterprise. So I'm proud today to stand here with Sean as he presents his experience about how modernization factories work. And with that, without further ado, over to you, Sean.
Thank you, Ashima.
Yep.
And thank you for many years of partnership and all the hard work on the program. Thanks to the team.
Absolutely.
All right, so let's talk a little bit about modernization factories. I already introduced myself. I've been with the company 17 years, give or take. My background is in data centers, security. I've been doing cloud on AWS since 2012, and I've been doing transformation programs for probably the past 10 years. So we learned a lot about what not to do. I'm going to share a little bit about what does work today. Merck is a global pharmaceutical company. We operate around the world. We're known as MSD outside the United States and Canada. Our mission is to save and improve lives. So although I love to geek out about technology, this is the mission that we're really after. The faster we can go delivering infrastructure and services to folks, the faster we can get about getting after our mission as a company. So that's what energizes me every morning when I wake up and get to work. All right, I already mentioned I've been doing enterprise cloud since 2012. MSD was actually in the beta test for many of the foundational services that we have today, so VPCs and CloudTrail. So we have a long history of leveraging AWS for hosting enterprise workloads and sensitive workloads, regulated workloads and what have you. So we know how to do cloud well, but running a modernization factory is a whole nother story because you're dealing with all sorts of different applications and all sorts of different kinds. All right, so in order to get after this, we launched a program called Blue Sky about, it's been 3 years. 3 years ago, we launched Blue Sky, and our mission was to leverage cloud migrations as a catalyst to drive IT transformation. So it's not about Lambda, it's not about Glue, it's not about fancy services, although those are certainly important in the context of our architectures. This is more about ways of working, changing how we build systems, how we deploy and manage those systems at scale. We're talking thousands of applications running around the world of all sorts of criticality and durability requirements. Ideally, the program will be returning money back to the business to be able to invest in other things other than running infrastructure. We've been very successful with this program. And again, one of the big partners that helped us along the way has been HCL. They've run one of our factories as a part of the program. So I just wanted to share some of the learnings we've had running factories at scale. You think when you hear factory, like you think the old-timey Ford factory, right, where they're putting together the Model Ts and bolting the wheels on, and everything's exactly the same every single time. It comes in one end, it comes out the other end. Like, that sounds great on paper, but that's not actually what you end up with when you start cracking into a data center that has workloads that have been running for 25 years in it, right? You're going to see all sorts of different things, and it looks a lot more like this, where there's stuff all over the place. You make decisions you'd regret later, but you had to use them in order to advance the mission. Sometimes revisiting those decisions to bring them up to another level. Managed chaos is sort of what the goal is with modernization factories and continuous improvement. So to distill this down, I wanted to leave you with like the 5 things that I personally learned along the way to running a factory at scale. All right. First and foremost, you got to have standardized architectural reviews for everything I've talked to a lot of peer companies of ours, a lot of companies in other industries. I've done consulting, had conversations with all sorts of different leaders. The number one thing I always hear is like, architecture takes too long. You can't make your teams all go through some sort of a centralized architectural review because it takes too long, humans don't scale, yada, yada, yada. That is indeed true, and you can indeed create bottlenecks with architectural reviews. But I would challenge that you have to find a way to be able to scale your architectural practices. If you don't, you will have people building things that you will regret that they built. And you will inevitably have to revisit those workloads and build them again on the other side of building them the first time. So take the time to create an architecture process that can scale. For Blue Sky, we created a process we call the TSA, the Target State Architecture Process. It was the first thing we launched when we started the program. We literally had 3 architects that all they did was look at architectures all day, every day. I don't care if it was a single load balancer, 2 EC2 instance application, or 5,000 different services all knitted together. We looked at every single architecture to make sure that they were built to our standards and our guiding principles. That has paid huge dividends for us because now we've learned how to scale this process, we've standardized it. Teams have set expectations now. They know that, hey, I'm not going to be able to get my AWS account provisioned for me until I have a target state architecture. So I'm just going to go do my target state architecture before I even ask. And that has started this flywheel effect of just, we now have good architectural practices. Always room for improvement, but definitely a huge step. All right, clearly defined guiding principles. I mentioned this previously. These are our guiding principles. Literally, we wrote them on a napkin when we wrote these originally. It's not rocket science. Anyone who's been doing cloud for a while will recognize these guiding principles. Most of them are just lifted from the AWS Well-Architected Framework or other AWS best practices. The power of guiding principles, and especially ones that are simple as this, like go cloud first. All right, we had to write that down, so for the sole purpose of being able to point at it and say, hey, our guiding principles are this. It's number 1 on the list. Why aren't you going cloud with this workload? Why are you going in the data center? So like you write these things down, and then you refer to them continuously throughout the course of the program. And you have to be very diligent about calling people out when they invalidate a guiding principle. You have to live by these things. We stole the idea from the AWS leadership principles. Like anyone who's worked with Amazon folks knows they have the Amazon leadership principles. They refer to them continuously. It's part of their culture. That's where this idea came from. Write it down, hold people accountable to the guiding principles, and use them to drive the strategy, which then ultimately turns into a more effective factory because you're not trying to build things that you shouldn't be building in the first place. You're building things that are aligned to your guiding principles. All right, number 3. Strong technical talent and technical leadership. I put the word technical in there twice for a reason. Like, you need technical people who understand how the cloud works in order to run a technology transformation program. Like, I talk to a lot of customers who are like, hey, I don't understand why our technology transformation isn't working. I was like, how many senior solution architects do you have on the program? How many certified AWS professional architects do you have? Like, none. I'm like, why do you think your program's not working? You don't have anybody who knows how things are actually supposed to work. So how are you actually building a factory that it will work? We spend a lot of time, myself personally, I spent a lot of time looking at architectures. I'm not a currently certified architect, but I was a certified architect at one point in my career. I'm also a certified security professional. Like, I personally look at architectures and call product managers and ask them questions like, why did you do this? This is the worst architecture I've ever seen. Why would you ever build this? You should be building something that looks like this. And then we give an example of a pattern that we may have. Or of another example from online that you can download. There's lots of material on architecture out there. Use it. And you have to have leaders in place that understand that it's a bad idea to just build monolithic EC2 instances and just have them running by themselves in an availability zone. Like, nobody would do that. Why would you do that? Without the leadership able to make those calls, then it becomes a line level decision where you have peers and it becomes very opinionated and people start arguing over architectures. Like, you need to have an architectural hierarchy. You need to know who's making the decision and who has the decision rights on architectures, and you need to set a very high bar and hold people accountable to it. Only then can your factory take those patterns and learn how to scale and implement them effectively. Okay. Pre-existing knowledge of the apps being modernized. This is a tough one. I've been a consultant, as I mentioned. Many times, companies will bring in third parties to help modernize their applications. If you're an engineer, or if you've ever written software or done any sort of engineering or architecture, you'll know that it's very hard to come in and take somebody else's work and just learn it in 5 minutes and then figure out how to modernize it. Especially when it's very large, complex applications that have been iterated on for many, many years. It's very, very challenging to do that. Typically, the documentation is terrible, and the people who built the thing are either retired or long gone or working on something completely different. One of the keys of our success with the Blue Sky program and with the modernization factory that HCL is responsible for is that they've been a partner for a long time. They know a lot about the applications and the infrastructure at our company. So we were lucky in that we were able to turn to them and say, hey, can you take this latent knowledge you have of the environment, because you've been here working with us for a while, and can you start to expand that up the stack to understand more about the applications themselves? Or for those apps where you're already supporting them, get the team here that has been supporting that application, let's get them in a room and let's start figuring out how do we re-architect the thing. That allowed us to fast track a lot of the early days work on going through a portfolio of thousands of applications and looking at their architectures one at a time. If you can go to the partner and say, hey, take 100, you go do that work, come in and we'll do a review session, and we can start to scale this thing more quickly so we can divide and conquer and get that work out the door. We also need to write it down as you're doing the work. It's another big challenge that a lot of companies I've talked to have is they have defined practices but are very loosey-goosey with the documentation or writing anything down and getting standards documented. Like, take the time to actually write it down. It's amazing what will happen when you take it out of your head and put it on a piece of paper. Suddenly things start to move more quickly. All right, and last but not least, continuous feedback between the factory and the supporting products and services that the factory is using. So at Merck, we've been on a mission to implement a product model for our infrastructure products in my own shop. So we've been slowly transitioning our legacy infrastructure teams to product teams. So for example, we have a Linux product and a Windows product and a containers product, and those products have product managers. Our goal is to have those product teams creating products that are useful to their customers, just like AWS creates products that are useful to all of us. We viewed the factory as a customer of those products, not something separate from, not some magical thing that you put in a box and just let it go run. The factory is actually a very big customer of our infrastructure products. So the feedback that is generated out of the factory as they're working and trying to use the products that we're making is incredibly valuable to our product teams. So initially we had this sort of, when we first launched factories, we had this sort of strange disconnect between the factory was trying to go off and solve every problem themselves and then come back and talk to the product teams after the fact. Once we realized, hey, why are you reinventing the wheel in the factory? Just feed the feedback right back into the product teams, let them iterate on the product and give you another release. It sped everything up because now the factory could just pause the work, wait for the product enhancement to hit. One sprint later, they have a new product feature that allows them to go forward with their work. They pick it up and back into the factory it goes. Like, that feedback loop resulted in, number one, better velocity in the factory because they're able to understand, hey, we don't have to solve everything. We just have to solve the stuff that's architecturally related. If it's a product problem, give it back to the product team, let them fix it, and we wait for them. And number two, our products got better as a result of taking that feedback from the factories. Our products have matured incredibly fast based on all the feedback and great work that the teams on the ground have done in the factories. And we're talking about hundreds of people here using these products. So it's a really powerful feedback loop that we've gotten a lot of benefit out of. All right. And with